Okay, so Extrema, so yesterday I did not restrict the functions, right? So I gave you like x squared, right? We checked that or something similar to it, a quadratic, but we did not restrict where we looked at it. Okay, that's not quite the right graph. We'll make it. Okay, small adjustments. Today, we're going to do something to be more specific. So I would maybe restrict it from -1 to 2. Yeah. Oh, that's supposed to, okay. From -1 to 2. Okay. So none of this up here would matter. So to classify Extrema as absolute or global. Okay. So that's where we're headed today. And let me show you. Let's start. Do you want to show the polynomial? I kind of showed you one yesterday. Sure. It would add one more example to the day, where I can just do a natural log and a sine cosine, and then something with a cusp. All of the above. Okay.
Are we gonna have time for all of them?
This is all we're doing today. Okay, so let's say something like find the extrema of, and we'll do 2x cubed minus 15x squared plus 24x plus 7 on 0, 6. Okay. Zero to 6. So we need to find the critical points, right? We're looking for extrema. So first step, derivative, okay. I hear mumbles.
6x squared minus 30x plus 24.
Okay. And? You have to set 0. It's very important on a free response that you actually do this, because they give you a point for doing this. Okay. It's the easiest point on the 0. Okay. Now you can start your work. Okay. Factor? Yeah. So what are my critical points? Okay. Here's where absolute extrema changes it just a little bit. Okay, yesterday we did a sign analysis just to show if it was a min or a max, right? Okay. Can be higher or lower than these critical points, right? So point, point. At an endpoint too. So we have to consider 0 and 6. Okay. We do that.
less than or equal to 6?
Yes.
Okay.
Yeah, so if you wanted to write it this way, you can. What in the? Okay, I'm losing my mind here. You can write it like that too. Okay, so we're just gonna do a table 0, 1, 4, and 6. We got our critical points and our endpoints, right? And then we're gonna test them in F. We don't need to worry about the derivative. Okay. Yesterday we used the derivative for local min and max. Let's use F. So what's F of 0? Okay. What's F of 1? Well, you want to click on that one. Minus 15. Negative 13 plus 24 is 11 plus 7, 18. Have fun with that. Let's look in the book. Negative 9. And what's F of 6? 40. 3? The book says 43. Uh-huh.
It would mean
Nope.
that 4 is the
All right.
absolute.
We have our absolute min here. And then sometimes you have to state what that is. So the absolute minimum is negative 9 at x equals 4. Right, so the value is how tall or low it is. That's our minimum or maximum. And then the x value references your left or right. So, and then here's our max.
Your absolute max?
Yep, because it's higher than all the rest of them, right? So absolute max is 43 at x equals 6. Okay? And you can kind of sketch what's 0, 7, then it goes 118, it goes to negative 9, then it goes 43. So you can kind of see what that looks like, right? But we're not worried about anything outside of 0, 6. All right? Enough? Okay. Okay, so 0, 7 here could be a local minimum, and this is a local maximum here, right? So, all right. Again, this procedure is the same every time. If you're looking for something that's an absolute, okay. All right, let's do something a little bit more difficult. Let's do a natural log. Okay, how about x squared minus 8 ln x? On 1, 4. Same procedure. Remember the, right? The 8's there, so we'll just leave the 8 multiplied. Ideas? What's next? Algebra expert. So 8 is 2x squared. You can divide by 2, square root. Worry about the -2. This, when you root, about it. No, it's not in the interval, thankfully. Okay, so mathematically perfect, we would get x squared equals 4 when we square root that positive or -2, but -2 is not in the interval. Okay. Yeah, that's your endpoints and your critical point. Plug them in. Okay, so. And what's the height? What's natural number 1? No, it's 0. Okay, so 1 gives us 1. Guess. F of 2. 4 minus 8 ln 2. Or whip out your calculator and dial it in.
Got 4.
And really?
Wait, is that -1.54?
Yeah. Okay. So where's our min? Of at x equals 2. And absolute max. 4.9 at x equals 4. Okay.
So the only time it's an absolute max.
This has no interval originally. It's an absolute minimum. With the work we know that it is the bottom, but given an interval and after an absolute. A gravel processing plant processes gravel at this funny equation per hour. What is the maximum time that the gravel plant is processing, or the maximum amount of gravel process time t? Okay. Yeah, and then you'd have to do this math, and you would say, well, at time 6, they're producing 43 tons of gravel an hour. So, yeah. So usually a word problem. Okay, let's talk sine and cosine here. And we'll make it an ugly one. Right. That's right. 2 pi. You just have different functions to consider. Okay? So, who got to pick on today? Hunter. What's my first step to find the extrema? Okay. The derivative. I'm hesitating. The chain rule. Okay, so what's the derivative? Okay, outside function here. Bring the power rule down, copy inside, and then your new power is 1, right? Now you can do your derivative inside. Okay? Yeah. Yep. Okay. What's the next step? Randy. We pick on Randy today too. Okay. And I'm gonna make it a little bit more friendly. Right, because there's a cosine one, I can factor it out, right? So I took a cosine out of each one, and I left 1 minus 2 sine x. Okay. Now we can do remember, cosine does this. Locations. You can also think unit circle. Problem. Think power 2. 90 and 270. Okay. Where is 1 minus 2 sine x equals 0? That means so subtract 1. Unit circle. Where is the hardest sign? Remember, sign is the y value. And then here, power 6. Yeah, so I'm going to come with geometric. 1, 2, 3. Sine is root 2 over 2 at power 4, and sine is root 3 over 2 at power 3, because it goes up. Cosine goes down, so it starts big, root 3 over 2, root 2 over 2, 1/2, 0. Okay. You can also, do it this way, but do not need anything down here because sine is negative. Right? The y values are negative down here. Unless our book says otherwise. It shouldn't. There should be 6 of them. Yeah. So now we just do our table.
But that's height by the,
Yeah, these are our critical points, right? And then you have your 2 endpoints. So I like to put them in order. This is just me being me. Okay, so in order. That way, if I'm looking at the function to right, I can kind of visualize. And now we analyze them. Okay, and there's the calculations. They're kind of tedious, but we get her done.
I'm so confused on how you got the pi over 2, 3 pi over 2, and pi over 6, and pi over 6. Look at the 6. I don't do.
Okay. Do you have turn in your book to the front cover. You can take out your unit circle. There's a unit circle in the front of the book. That's where I'm headed. Remember.
Oh, I see.
Okay, we're looking, so cosine 0, right? Oh. So look at the 90-degree mark. The x-coordinates. Cosine 90 or pi over 2. So, and then b, cosine is 0 again. The x value 0, that's 3 pi over 2. Right? And then look where sine, the y value is sine 1/2.
Is that pi?
5 pi over 6.
Okay,
Okay? Now analyze these values. And this is, again, a unit circle exercise. Plug 0 in. What's sine at 0?
Sine of 0 is 2 pi. Oh, wait.
Okay.
Is that anymore?
Think sine. It's 0. So here's the graph, or you can use the unit circle, the height. Okay, so 0 cosine is 1. So 0 plus 1. All right, it gets a little messier. Pi over 6. What's sine pi over 6? 1/2. Cosine is root 3 over 2. You have to square. Okay. It actually gets roots and you get a fraction. So 3 squared, 3, and this is 4, plus 1/2. Yeah. Okay. So this, like I told you, this is a very common no calculus problem. We probably will not give you this many points to analyze, but be prepared to chain rule. But set equal. Oh, get on the derivative. I see a lot of shaking, yes. And a lot of.
I don't think I'm in either of those.
Wait, what happens to 1 minus 0?
The 1, what's the derivative of a constant? 0. I like to rewrite these because it becomes very obvious. Okay, can this ever equal 0? You're going to multiply that out, right? But now the x is gone. Okay, it can't ever equal 0. Okay, there can never be a horizontal tangent line. So let's write out what here's our goal. Where is it not differentiable?
You have to find it.
Okay. This little side note. What is the denominator equal for it to be undefined? Where does that happen? No. We get 1 in, I get 0 times 0, right? So at x equals 1, it's not differentiable. Okay.
So wherever it equals 0 and 1, whatever number.
Yeah, basically. Yep. But be careful, it can still happen. Okay. You just don't have to consider the denominator. Okay. Yeah. Such is life. Okay. What else did we say? Now we're just you're using because this is either a corner or a cusp. The function is continuous at 1, right? It just returns a value of 0, or sorry, of 1. So the function exists at 1. It's just not differentiable. So you know something is happening, like a corner or a cusp. Let's think of 2 to the 2/3. 2 squared is 4. What's the cube root of 4? Yeah, I don't know either. 1 minus the cube root of 4. Anybody? Yep, didn't think so. Okay, it's negative 0.59. F of 1 is 1, 2 is 0.
Oh, yeah. No.
Okay. Do you do this calculation? Minus 1 is 0. 1 minus 0 is 1. 2 minus 1 is 1. Any exponent of 1 is 1, so 1 minus 1 is 0. Okay. So you have your and your max. Okay. So it's the same process as before. You just have to deal with it being not differentiable here. No, this it's critical because something happens there. Increasing to decreasing or the like. Okay. What? No, we don't care. We just think, hey, look at that. It's the tallest spot. Awesome. Done with my calculus. This function, looks like that. So, okay. All right, are you good? Think you can do this? The hardest part of a lot of these is the algebra. Honestly, the derivative becomes very easy. You get so used to doing them. Algebra is where you might hit a snag. So I wrote your homework down yesterday. Do you need me to write it again? All right. Let me go shut the video off. You have about 10 minutes.
So you're telling me that you don't want to say 7:30?